Now I'm not really there, but now I'm blue sheeted there.
You can be blue sheeted in more than one
Yes, I don't
thing
want
per
to
session.
because I'm not there.
Um, Muhammad Bukadir asked me about his thing.
The best thing. What?
Yeah, I don't remember what his thing is.
Mathematical best.
He said that he reminded us a couple of times and we didn't reply to him.
Oh, so what? Who asked what?
Muhammad Bukadir?
Oh, okay. So this is the one of the other drafts. I think it was ADD, right?
Probably. Yeah, ADD was at least one.
Yeah. Okay.
Yeah, the ADD.
Yeah. Okay, now we can start. All right, so this is IPSEC-ME. Can the remote people actually hear me now? Just checking. Do we have any remote participants?
Okay. John McHagan.
Okay, well, we get commented that they can hear us. Okay, so this is IPSEC-ME working group starting, and I'm Tero Kivinen, and this is my co-chair, Joab. And our responsible AD is not here because he's in TLS, but we have this, spare AD, Paul, here. All right, let's go forward. Next page. You have the slides. Okay, so this is note well, that is all probably noted well already. And text is on purpose so small that you can't read it because you have read it already beforehand. Okay, go to the next slide.
Remind people about their
Yeah.
past obligation.
Yeah, I think it's the next page. So, administrator tasks. So you should go to the Meet Echo and log in, even if you are not, following things there. But you should be the blue sheets are generated by that. So you should go to Meet Echo, log in. So I should probably make it a little bit more clear if I talk without my mask. So, and there's a Jabber, which actually should be probably replaced with the Tulip link, but I don't have that one yet. And there's a notes document that is already halfway populated. So we would like to get some note takers that would actually add some stuff to the notes. Any volunteers?
I see Peter nodding his head.
Oh, Peter is nodding, but he sent me a message that he are not willing to do that this time. Okay, Paul is doing something. Hopefully somebody will help because Paul is also presenting at some point. It should be only going through the discussion. So, but okay.
I'll follow the.
Okay, we can follow it
the
some.
Zuli program, I guess.
Okay. Oh, it's a chat room. Okay.
Yeah, chat. Technology doesn't matter.
All right. So and and you should be wearing masks here because well you are not presenting or eating. And what else we do? Nothing else. So let's go to the next slide. So
we didn't have a slide about the mask mandate.
No, I don't have that one. Yeah, I just mentioned it.
Yeah, just remember that there is a mask mandate.
Yeah. All right. So this is our agenda. So we go to did the note well technical difficulties. We didn't have those at this time. No, probably no agenda bashing, or does somebody want to add something to agenda? And then we have a document status and work items. We have, oh, actually, all of these work items are something that are not necessary in charter of the current work, but should be useful in the, or might be getting worked on. I don't know. Any comments on the agenda? Okay, so let's go that forward. So one of the reasons we have been so little things to do is because our publication requested queue is getting long. So we have one RFC at IETF version 2 intermediate was published as an RFC since last, I think, and then we have two documents in the ISG evaluation, and then we have a couple of in IETF last call and AD evaluation and multiple key exchanges publication requested. One of the comments I had for the multiple key exchange is that there was some discussion about, some people doing some interrupt testing on that. So it might be actually useful to get some numbers for that for IANA. So it might be perhaps useful to do the early allocation of the, request for early allocation of the IANA allocation for multiple key exchange, because I think it's stable enough that we don't need to do anything. The numbers are not going to be, the IANA allocations are not going to be changed. And then we have this one document that is labeled IPSEC that is waiting for chair review and write up things. And then we have three documents that in some way are in working process. The out announce I haven't actually seen anything from that for some time. GIC version 2 is still waiting for more reviews, but I think we are not going to get those. So I think I will kick it forward anyway. It's still in the last call from the beginning of the year. And working group last call, I mean. And then there's this add IC, which I think is probably quite ready to go to the, working group last call and then forward. Okay, I think.
Comments, objections?
Right. So yeah,
I haven't hit the button yet. Let's go with Valerie.
okay, Valerie, you go first.
Okay, just want to make an update on these last three documents because.
Can you speak up a little bit, because I
Well,
can barely hear.
Can you hear me?
Now we can hear you better.
Well, okay, because I'm co-author or author of all the three documents, I can just make a quick update. So GIQ2 is waiting for reviews, and as far as I remember, at the last IETF meeting, a few people volunteered to review this draft, but this didn't happen, unfortunately. So it is just a friendly reminder for those who not committed, but at least agreed to review this draft, that the draft is still waiting for review, and I'll be happy to receive any feedback. And what about our announce? I think the draft is updated recently, and I don't think it is ready for last call, but I think it is in some point where a review is very helpful, and probably to the next IETF, the draft may be ready for last call. And what about IPSEC-ME at IC? And we, as co-authors, think that the draft is stable and ready for last call. And we already wrote to the chairs requesting the last call.
So you mean the multiple was the last one was the multiple key, or what was the last one?
Okay, so ADD.
Yeah, sorry.
Well,
and Mohammed also says in the chat room that he thinks it's ready.
So the seemed to be a comment that the IC is ready for the last call, and GIC version 2, I think there was somebody starting with P or something like that who promised to review it or something like that. Okay, next comment, Hubs.
Yeah, Christian Hop. So we promised to be giving public source code for IPTFS the whole time we were writing it. We finally got the publication, you know, the okay to publish it. So just pushed up the original reference um, implementation, which does the whole standard. That's based on VPP. And right now we're writing a Linux version, and we also got the publication okay on that. So that's also been put up on GitHub. I can send some links to the mailing list.
Yeah, that would be very useful. And I think actually, don't we have some kind of code repository thing that actually provides links to the implementation? I think we have something like that. So you should actually check out that and make sure that you publish in that there also.
Okay, yeah, and and we also did Strong Swan changes a long time ago for the Ike stuff.
Okay, so that's for the current working groups documents. So next slide is, I think we are going to be presentations. So these are all not necessary in the direct charter items in IK version 2, but sorry, IPSEC-ME, but might be considered as a small enough extensions to be added without charter changes. But we have to discuss that later after we get to the charter discussion. So Daniel.
Hi, everyone. So this extension is well, the IPv4 downstream fragmentation notification extension, and the main purpose is when a security gateway realizes that it is undergoing fragmentation and is doing a reassembly or processes, it can notify the other peer. So next slide. So the reason we want to avoid fragmentation is that when a security gateway needs to do some reassembly, it requires some resource. And in case of heavy loads, you have the identification ID that is not large enough to prevent duplication. So it has a sort of security issue. And the problem is only happening for IPv4, where fragmentation can happen in the middle. Next slide. So basically, the scenario is you have two gateways and an IPv4 network between the gateways somewhere. So one way to do, if fragmentation is a problem, you can set the bit to the don't-fragment bit to 1 so that you avoid fragmentation. The problem is that a router is in the middle that is receiving a packet that is too big, may send a packet too big ICMP message, but that message is unlikely to reach the gateway. So the gateway is sending and is not receiving the response. I mean the information that there is a fragmentation happening, and so the system remains stalled, which is named as black holing. So this is one of the reasons we don't set this DF bit to 1, but instead of to 0, so that fragmentation can happen. Next slide. So what we propose is that when a downstream security gateway is proceeding to reassembly, it can proceed. We're not preventing that, but you can also advertise the sending gateway that, hey, you're sending packets that seems a little bit too large for the network, and we expect. And you can also send MTU value, so that security gateway can adjust the packet that is being sent to that receiving gateway. The principle is very similar to the ICMP packet too big. It's basically the same. And this is aligned with the recommendation of RFC 8900 that recommends that fragmentation is being handled by each layers by a specific mechanisms. So the idea is to rely the least on the IP signaling. Next slide. So you have the supported agreement to support the extension. And when you have that fragmentation happening, you send the notification, which is designated as a IPv4 downstream fragmentation. The receiving security gateway can be initiator or responder. It is not related to that. Next slide. So what do you do? Oh, so that's the very complex data sent by the security gateway. So that's the data carried by the extension. So it's actually only the MTU value.
32 bits.
Sorry?
32 bits.
Oh, well, you have multiple lines. So next slide. So what we expect, so it's one thing that you receive that the fragmentation is ongoing. Then, another thing is how you handle that. And you have different ways. One way is that you advertise your peers in your back network that fragmentation is ongoing. So typically you can send a packet to big message to those so that the inner packet match the MTU advertised by the downstream security gateway. If the packets are, the inner packet is enabling fragmentation, fragmentation can be also handled by the security gateway. It's one way to do. And the security gateway can also perform outer fragmentation. So there are different ways this could be handled, and we leave that to the implementation. And I think that's all. Thank you.
Okay, go ahead, Valerie.
I think that this draft must be subject for transport area review because, I remember when IP fragmentation was developed, there were a lot of discussion with transport guys because they think that, fragmentation is their realm, and they think then they know how to do it right, and don't want that we reinvent the wheel. Because, the problem that a packet too big ICMP message is often blocked by the network is not new. And as far as I know, it's long ago another approach is used, and packetization layer passing to discoveries. It doesn't rely on this ICMP message. It's RFC 4821. And so it's probably worth to look at the RFC, and it is updated for UDP. I don't remember the RFC number. It's quite new, something like 8899, because initially it was for TCP only. And I was told at the time by transport area guys that most current operation system supports this RFC, I mean packetization layer passing to discovery, and don't rely on ICMP too big no more. So I'm not an expert in kernel, but I trust them. So probably this is not a problem. This is not so big problem as you described. And another concern that I have, we have an IPsec architecture RFC 4301, which describes in very detail how ICMP error message should be forwarded by security gateways, so that this error message, including packet too big, get reached for the initial sender and so that everything works. And it's, I don't know whether everybody implements, because it's quite complex, because traffic selector for TCP must also include an ICP message that is related to this TCP stream. And it requires some additional code in the kernel, additional logic. But it is. How we violate with the draft the IPsec architecture RFC? Another concern that came to my mind was that probably this approach is not, it has its drawbacks, because it assumes that packets, outer packets will have don't fragment bit set, so that they are not fragmented. And once the receiving gateway reports the MTU. And again, the transport guys think that sending host must always try to increase MTU, pass MTU as much as possible, because route may change, and so the MTU may change. So that's why a sending host sometimes tries to use a bigger MTU. And in this case, I think that some additional logic must be implemented in the security gateways. It is duplicated by what the logic is implemented in the sending host, so that it must not stick to a particular MTU value that was reported initially. And sometimes it must try to increase this MTU and see what happens. So my concern is that it's an area that is belong to transport guys, and probably we don't want to reinvent the wheel. And one more question, just for the slides. Can you come back? I have a question. Back. And one more. And one more. One more back. Oh, no, not the very beginning. The next. Next. Oh, well, that's one. Previous. Well, I don't understand. Is it the last message in the diagram? Is it the standard IETF exchange that requires a response? Because you just show it as a one-way message. So if it is a one-way message on IETF layer, that it will break the fundamental principle that every request must have a response. Or am I missing something?
Yeah, so I mean, I didn't get really much the concern, but when one gateway is realizing it's doing reassembly, it's just sending the notification. So the mechanism is very...
Okay, what message ID will this notification have? How it will how it will be related with the message ID logic on the receiving side?
This is given. I think it has to be, just the informational message with the, round trip.
Yes, I think
that I think it's just your. I think that's the only way to actually get it working, is to have an information.
So we need a response?
Yes, you need a response.
Yes,
the response can be
empty.
Response.
Okay, right.
Valerie, this is Yoav. So every document that goes through this working group eventually has to go to the transport area directorate review. I'm assuming that what you're advocating for is to get an early review even before we talk about adopting the draft, right?
Probably yes, because, well, I remember when IETF fragmentation was discussed, I get a lot of feedback from transport area guys, and this feedback was mostly that you do everything wrong. Well.
And we do, okay.
Okay, thank you.
So how we do that? Do we send that to the transport area director?
Yes, there's a button on the data tracker.
Okay, let's. Yeah.
Okay.
Okay, instead of giving us at the share, but that's you know, just individual here. So one of the things I have for here for this slide is that I don't see any need for the downstream fragmentation supported notifications. You are just sending one status notification, and every implementation out there, if they get an informational notification which have status information they don't understand, they just ignore it. So you don't need to have any kind of this kind of negotiation, do we support this or not? And I'd rather have less of this kind of negotiation when we don't need it.
Yeah, I mean, specifically, if the implementation doesn't recognize IPv4 downstream fragmentation, it won't recognize IPv4 downstream fragmentation supported either.
Yes, that's true. Okay, and if you go to the previous slide, I think there was some cases we have problem with there. What's the? No, actually, I have a couple of topics. So actually, one of the other topics I had there is, yeah, you can if you have comments on that.
Sorry, Paolo. So I think one use of the notify payload is that you can actually signal that you support this, and then the both parties can start sending these MTU updates. If you don't see the supported one, you don't have to generate. Otherwise, you keep generating these MTU things, and the other side keeps ignoring them because they don't support them. So it's better to not send them. So the supported notify would actually reduce sending, a round trip exchange message just for the notify that they don't understand anyway.
This document, yeah, that's true, and I think we can also say so that you can actually send. I mean, you are not sending things all the time. You only send when you notice that there is an MTU that you don't like.
Yeah, I mean, you don't.
So meaning you send one of them, and if nothing changes in the path, then you are not sending any more. And if you get, and of course we could say that. So when you receive one, you should send in a reply you should send a back other one if you support this. We can actually say it. So we can actually do the negotiation in the first one. So and then also I think the MTU is. I think we don't need to have a 32-bit. Long MTU there because I think we only have 16 bits usually. If you go 2 slides forward. One more. So I have no idea why you actually have a port 3 there. Why would the security gateway do the outer fragmentation? I think that's actually a bad thing. I mean, if you have something in the middle that fragments your packets, if the security gateway does the outer fragmentation, if something changes, he will never notice it. He will still fragment it in the small pieces because in the beginning there was something that was reducing the MTU to a very small one. So that's why I think it's better to just leave it, the outer fragmentation always to the network. So you could advertise your outer, but this is also actually bad thing is the problem with this kind of method is that you are only getting the packet notifications. So the notify you are getting is exactly the same as ICMP packet to week notify. And it should have an exactly same processing than if you would have received that one, which means that there is all kind of things that they say that okay, you should be forgetting this, you should be trying again with the bigger buckets and doing all kind of probes, and it is very complicated in a way that, and it's also mostly outside the scope of IPSECME. We don't actually have to specify that. I think it would be better. We could specify just oh, this is the way to send end-to-end packet to big messages for so you can actually feed it to the whatever fragmentation avoidance or path MTU discovery method you have.
Okay, so just to repeat, you would remove the.
Yeah, I mean, if we do that, then we never actually notice if something happens in the middle, because we never actually. Yeah, but if the MTU, if somebody in the beginning says, oh, MTU is 200, oh, okay, they agree to MTU 200, they fragment MTU to 200 and puts a dot fragment bit up. And then this node that was having MTU 200 goes away, and you could be able to use MTU 1000. You will never do that because you will never notice it.
Okay, so one thing when we talk about MTU, you have all this MTU discovery, and changes are never once forever. I mean, regularly you can send dummy packets. So that's one thing I didn't want to go into MTU discovery, or is it path MTU discovery protocols? So if you send dummy packets and so on, I think that's way beyond the scope of such a document.
So Palvarto, so if I remember correctly, we talked about this before, and you had only a downgrade process where you could get to smaller MTUs. And after my comment, I said you also need to probe to go back to bigger MTUs again. And I think you added text for that, right? That's the same draft, right?
I don't. So this draft is the first one. It's the first time I'm presenting it. So I don't think we have.
Okay,
ever
so
discussed
I
this one.
remember we had a discussion about MTU where you also suggested something about signaling this smaller, and I said, well, if you're signaling small MTUs, you also have to be able to signal bigger MTUs again. So I was expecting that to be in
Okay.
this draft.
No, I don't recall that discussion on MTU. But so I guess those are unrelated.
Okay.
This one is really coming from, we have an issue to operate our gateways, and this is one way we propose to solve that.
Okay, so then let me bring it up right now. If you downgrade the MTU size based on whatever process you define in this draft, you should also define something to try, and that's what Tira, I guess, said too. You should define something again to see if you can bring the MTU up again
Oh,
and
yeah, yeah,
send the
yeah.
bigger MTUs
Yeah.
again. Right?
Yeah. That's but this is what okay. So what you're saying is that in this draft we need to define a process to discover somehow the path.
No.
So we can bring it up. What I say simply is that you have when you reduce the MTU, it's for some time, and then you retry. This is the way I see that.
Right, but so, and that's my next point about where I actually want to go to the microphone, is that this actually requires a lot of talk between the kernel and Ike, right? Because now the Ike daemon needs to continuously look at the kernel to see if it's time to do bigger packets or smaller packets, or whether, it should act on unsecured packet too big that they do come in. You just usually don't trust them, and so should you use them as a trigger mechanism to do this? So I'm also getting nearer and nearer to Tiro's point, where I think it would be good to, I don't know, maybe not define how you should handle this, but just say like the IDM should talk to the kernel to get this information and then send these packets, and leave out of this draft how that works, even though that is a really difficult part to do. But that's, the operating system people should do that.
Yeah. So I'm unclear about your proposal. Do you want us to describe how we interact with the kernel and MDM2 or not? I think it's not.
No, I think you should just put a note in there saying that this is not just decisions from the Ike daemon. The Ike daemon needs information from the kernel, and they need to get this information somehow.
Yeah.
But I wouldn't try to define a mechanism of how to process them, what to do, like how to lower the limit, when to repro, because then indeed, to Valerie's point, you're in the transport area and you should listen to them instead.
Yeah.
Christian Hops. So Valerie was talking, he made a lot of points, but there's one in particular I want to stress. The transport area has defined a new method, right? And it's called like packetization layer MTU discovery. And it gives you exactly how to do this, right? Like when to probe, how to probe. But it's specifically designed so you can do it within your protocols, right? Within your packetization. So if you do get into the realm of like trying to report MTUs, don't come up with your own system.
Right? Oh yeah.
Use that 8899. And if it looks anything like you're doing that, you're going to have to do that, or the transport area is just going to shut you down.
Mm-hmm.
you know, you might be able to just, I mean, if it was me, if I wanted to stay out of the transport area trouble, I would just define a message that says fragmentation is happening. Like if you go beyond that, then you're doing MTU discovery, right? You're gonna be in trouble.
So this document, so you are saying that this method that they are describing, if the only input it actually gets is the fragmentation happening, there is no path, you know, MTU or anything like
Yeah,
that.
I think once you start reporting MTUs, you're doing MTU discovery, right?
If you can't report MTU, then what good is this?
I think you should do PLMTUD, right? I think it's worthwhile to actually go to 8899 and for the IPsec tunnel, why not? And because you would use your IKE packets with, and you know, you'd set probe bits just like they say. They tell you how to do the implementation, right? And you could use IKE packets to do this.
Use the mic.
Yeah.
If you use an IKE to probe it, it will be treated differently because ESP will be treated differently by the network devices to segment it.
You mean because the ports are different, or it might take a different path?
Protocol is different.
Yeah.
Yeah, this is actually true that the protocol 50 ESP might get actually completely different processing than UDP.
Right.
And IKE version 2 is UDP, and the other one is protocol 50. But this is actually something that is very, very useful to discuss and talk with the, you know, the transport area people.
Yeah, so I agree somehow. That was the intent, to not try to implement a path MTU discovery and that to have something light, and since it's very easy to get the MTU, to also send it. But yeah, I agree. So I don't remember why, but I thought that defining this.
Wait, back up, because you just said it's very easy to get the MTU, right? That's like that's the opposite of true, right? It's a really hard problem. That's why we have all these protocols to figure it out.
It's easy to get the MTU of the fragment.
No, because you don't know if the device in the middle split it in two pieces, or put as big in the first and then as small piece as the next. You don't know how the device in the middle might actually do whatever kind of you know, and it actually might reassemble it in some ways and you know combine them and you don't know what's happening.
Yeah. Okay, I see to that perspective.
Couldn't it be different for each SA because it's going to a different segment of the network?
Yeah.
Sorry, I'll repeat that. Couldn't it be different for each SA because each SA could be going to a different segment of the network? So the path MTU from the gateway to that segment of the network can be different than it is for another SA.
Yeah, but you only have one downstream.
Downstream? No.
The ESP packet goes entry.
Right. Yeah.
But so, is the recommendation to remove the MTU?
So yeah, I have it. So I was asking if there's any other questions or comments on this. So this is a little bit. I think we need to discuss more about this, and I think there is, you know, lots of things that I think this falls a little bit, you know, immediately if you go anywhere to describe how it actually is, the discovery is done, we go a little bit out of the, I would say actually we go out of the charter of the IPSEC. If we just, you know, send a very the minimal information that the transport area path discovery requires, you know, fragmentation happening, that would be completely okay, and it would be very simple, you know, what just one, rate limited notification to the other and saying, oh, there's some fragmentation going on somewhere, you should do something. And the next question is, do people think this document is useful? Should we actually continue working on this and think about this as a work item or as an item that would be interesting to other people?
I think this should go to the list.
Yeah, I think it's worth discussing on the list at least. A little
Okay,
bit more.
so we will take this to the list and hopefully people actually can. What's your plan? Are you going to pick Okay, so there were several comments coming to you that you should be working on. I was thinking about should we actually wait for the next revision of the draft and then start reviewing it,
think
or
the first action point is to discuss with the transport. Is it?
no? Yeah, yeah. I think that also you could actually find somebody who actually actively working on the transport area and talk with them and ask what their opinions about this is and so on.
Do we know someone that is passionate about MTU?
So touch.
Okay.
All right.
Okay, that's good.
So if there's nothing else on that, so this was go back to the list and then go to the next presentation, I think, which is the count-based SA extension.
Yeah. So in this extension, we want to. I mean, the thing we want. Next slide. So the problem is that when you're using a hardware to accelerate IPsec, the hardware has a fixed number of entries, and it is a limit. And when you have a simultaneous rekey, it means you have an additional SA. So the entry, I mean, you're using an entry that you're gonna delete later, but I mean, you need that entry. And if one of those entry, I mean, if you don't have enough entries, you cannot create an SA. So it ends up in traffic disruption. So we do, so the main problem is that redundant SA results in an underutilization of the hardware. Usually, in our deployment, it's a 10%. So but when you have smaller lifetime of SA, the underutilization reach 40%. So that's really something we would like to avoid and find a deterministic way to avoid those redundant SA. So next slide. So if you use a lifetime of SA using, so SA can be, the lifetime of the security association can be defined according to time or according to byte counts. If you're using time, then you can actually predict very precisely when, the lifetime is expired. But if you're using a byte count, it's much more difficult because it's hard to predict the traffic that is going. And when you have a traffic burst, you can make a huge jump. So it's not linear in that sense. And so how our implementation work is that every 2 seconds, we go through the S8 lifetime and we decide which is, we compare the lifetime and say which of the SA has expired or not. So, so when you have, with a lifetime defined with time, since you can predict, you randomize those and you end up in a uniform distribution of the lifetime. If you use count-based, because it's not a linear process. The number of bytes you receive is not linear. You very easily, in a 2-second time slot of traffic, you ended up in the randomization is not able to take that into account. And so you have a lot of those redundant rekey, simultaneous rekey. So the method we have works pretty well for time, but doesn't work for count randomization. And this is why we want this extension.
Sorry, Paul, can I ask a clarifying question? Are you talking that the problem is in general too many rekeys, or are you talking about the problem is that it happens too often that both sides rekey at the same time?
So what is the difference? So you say in
So are you afraid of 2 endpoints deciding at the exact same time that they need to rekey? Is that your problem, or is your problem just like I want to better predict rekeys in general?
Yeah, if it's one, I think it works fine. If it's multiple, that's a problem.
Okay.
And our problem is that we have a fixed number of SA, and I mean, we can use 90%, but we don't want to use a half. of
Okay,
that
so sorry.
resource.
So no, so okay, so you're not talking about simultaneous rekey, because you said simultaneous rekeys, which confused me. Because
Okay.
that is when the peers decide that they have at the exact same byte counter, they decide both to rekey, and then you've got a double rekey
Yeah,
happening at
that's the
same time.
problem. The problem is a double SA.
Well, but every rekey has a double SA, except if they do it at the same time, you
Yeah.
basically have triple SAs. Basically.
Okay, so that's
Four
the
times.
case we want to avoid. We want to avoid. Okay, yeah. So you have one S. I mean, when you have two essays per direction.
Okay, so you're talking just about the general rekey
Yeah.
process. Okay.
Yeah,
thank
yeah,
you.
yeah. So next slide. Oh, okay, that's the next slide. So, okay, another question is, why do we want count-based essays? So the main motivation for us is that the cryptographic lifetime of a key are based on the number of bytes that have been encrypted. So it's strictly bound to the lifetime of the key, as opposed to if you describe it in terms of seconds, it's two different metrics. And the other, but the other reason is that one advantage of using a byte count is that if you have a device that goes to sleep, and if during that time, if you're using time-based, and when he wakes up, he has a lot of essay that can be expired, and he notifies that very late. While if you use count-based, at the time he wakes up, he can handle the refreshment and the management of those essays. So that's one of the reasons we'd like to stick to count-based. Though, I mean, they are, I don't remember which are probably the IPsec architecture defines that you must support both. So there is no magic in how it works. When the P agrees an essay, they also agree who is going to play, who is going to start the rekey. So that's how the extension works. So next slide. So so the idea is that when you have a handshake, you have a notify payload that provides you some information, that propose you some parameters, and you have a response from the other one. And when it's done, both peer as agreed who is going to start the rekey. So next slide. So the proposal consists in providing for each transform a rekey value, which is going to be a random number, and depending on who's got the largest number is going to be defined as I don't remember, but either the initiator or the responder. And you provide an indication about the count-based lifetime you're willing to. So you provide your range. And this is done for every transform ID that are considered in the SA payload. So then once you have that, the next slide, the responder pick up one count-based lifetime, a rekey value, and next slide. And so, as I mentioned, they decide first who is going to rekey, and this is based on the rekey value. And then they set their lifetime hard and soft for the SA. So the idea is here, this value is 80%. I think I forgot to mention. This one is a lower or up to 80%. This one is greater than 95%. You had a little bit of random, and oh, I mentioned that. And so this is how you set those things. So even if, because the thing is that even if we agree to, if one is agreed to say, yeah, I'm going to be the first one, there is a commitment to do that. But if he fails, I mean, we still have the 5% to realize that and to perform the rekey. Next slide. I think it's over. Yeah.
This is Derek Kivinen. So one of the comments that I have that usually when you are doing count-based essays or this kind, you actually don't really care about the risk incoming, or you care about, rekeying your own essay that you are, sending, because that's the one that you are actually running out of the. So if you actually, then it's very uncommon to actually have a, so you have so symmetric traffic that you are sending exactly the same amount of bytes in both directions to be able to start the rekeying at the same time. And even in that case, if you have if you got the previous slide, if you have that, responder using, 80% and the, IETF using 80% and the responder using 95%, that will take care of that usually. So I don't really see the issue. I think all of this is actually more or less implementation guidance to the people who actually implement the rekey thing. And one of the things we actually did in IETF2, we moved this whole thing, when to do rekey, how to do rekey, whether to bucket based or byte based or time based, out from the I cannot negotiation. It's policies, local policy. Different peers has different policies, and they are willing. They can enforce them as ever they like. And if they have very different policies, if other one sends I will only send 1 gigabyte, the other one says I will send 10 gigabytes. The one that is sending 1 gigabyte will always retransmit, rekey first, because he is running out of it. And in that case, he actually probably wants to actually check also the other direction if he wants to enforce the other end's sending essay. But usually, the only thing that people are caring that what they transmit themselves. So I'm a little bit. I don't think that we actually need the draft. Is the thing that I'm saying. I don't think we actually want to bring back the negotiation of the lifetimes. It was really painful in, IETF1 because there were so stupid implementations. This is mostly because the implementation was saying, oh, they must have exactly the same, values, otherwise we don't accept the proposal. So it was really hard to get, okay, you want to have 1 megabyte and 10 megabytes, and it was really difficult. And so that's why actually, leaving it all to the policy, to local policy, I think is best.
Okay, so that's correct that the problem arises when we do have on the deployment where the traffic is pretty symmetric.
I think Valerie is next, or do you have a clarifying question?
Sorry, can I clarify? Because now Tero talked about simultaneous rekeying again, and I just thought I had clarified earlier that was actually not what we were talking about. We were talking about that rekeying in general causes multiple essays, and that was the problem. So now I'm again lost at what the problem is that we're solving.
My understanding is it was really about rekey, simultaneous happening. Both ends deciding to do rekeys at the same time causing redundant essays to be created, which will be cleared out at some point, but usually, not necessarily quickly enough for their uses. And of course, the one that they have, the problem that they're actually doing this checking every 2 seconds only, might actually cause that they actually suddenly have tens of essays they need to rekey at the same time, because I think most of the implementation actually do every time they actually send the packet, they verify oh, it's getting close to the rekey time packet count or byte count, and send a trigger to the user land to saying that, oh, you should start rekeying quite soon. But I think Valerie is the next. And
well, I mostly agree with Tara, and I wanted to say to say the same thing. So just more consideration to support the position that this protocol is, I think, is not needed because it can be achieved by a simpler method. First, the need for limit the byte count of the assay comes from the cryptographic need to limit the amount of data that attacker can get to provide to mount an attack and to brute force or something, use some method to get the key. So it is from this point of view, the most sensible is to count the number of bytes on the sending side. And there's very little point to count bytes on the receiving side, because once the data is sent, it is already in the network. And if you receive it, the possible damage, the possible damage that can attacker, the possible advantage that attacker can get is already received, because attacker has already seen this traffic and it get it. There is no count. There is no point to count number of bytes on the receiving side. Well, there is small point if we count side channel attacks, but generally, if we are in a Dolev-Yao threat model, the host itself considered secure, and only network is considered a field where attacker can operate. So the point is that the most sensible is to count the number of bytes sent and not received. And if you do it well, okay, it is possible that with almost symmetric traffic, you will get a simultaneous rekey. But if there is an asymmetry, and well, I don't know the application, but in most cases, there is some asymmetry in traffic. The sending side will receive pointer key, and it will rarely happen simultaneously. And one more point, network sometimes drops packets, and so the count of bytes that sending side and receiving side have will very often will differ. And in this situation, it is possible consider a situation. For example, PS decided that the receiving side will rekey, okay, according to your protocol. But the packets, every second packet gets dropped. That way, what to do, what the sending side should do? Should it violate its policy and send more traffic than it is required to be sent before a key? Because the receiving side doesn't get the traffic. The packet gets dropped. So I think it's not very good from cryptographic point of view. So I think that sending side should decide when to rekey.
So I didn't get why we should only monitor the sending side and
because
receiving side is meaningless.
Because the main motivation for limit the byte count sent on the assay is to limit the amount of data that the network attacker gets to mount an attack on the key. So when the sending side sent the packet, the attacker has already get it. There is no point to count on the receiver because the packet has already sent.
Yeah, I thought of something like an oracle for receiving, but that doesn't make sense.
Well, if we consider the host secure in Dolev-Yao threat model, the host is secure against attacks. So if it don't consider the side channel attacks, well, we can consider them. If you consider side channel attacks, there is some point to count number of bytes on the receiving side too. But generally, it's a very complex topic. And
Yeah.
with simple Dolev-Yao model, host is not acceptable to is not accessible to an attacker, only network. So once the packet is in the network, it can be attacked. Once it is received by the host, attacker cannot get to it.
Mm-hmm.
Well, with Dolev-Yao.
Okay, so that was the first comment. And the second was?
The second was that the network can drop packets.
Oh, yeah.
And consider the lossy network that drops every second packet. And consider the situation with your protocol that the peer decided that the receiving side will rekey. In the situation, before the receiving side starts rekeying, the sending side will have to send twice as many data as it is safe from cryptographic point of view, because it has a limit not to send much than, I don't know, some predefined number of bytes, but the packet get dropped. So what the sending side should do in this situation? Should it stop sending? Should it rekey itself? Should it continue sending and thus give more data to attacker?
Well, the thing, if one out of two packets is dropped, then one lifetime is going to increase much more than the other.
Yes.
So actually, that's going to create
and there is a damage because if the receiving side, according to your protocol, must rekey in this situation, before the receiving side gets enough data to decide that the rekey is needed, the sending side has already sent much more data and gives this much more data to attacker. Or should it stop sending?
Okay.
Or should it
Okay.
rekey itself? So I think it's a bit dangerous from security point of view.
I am happy if you bring that attack on the mailing list.
Okay. Okay.
That's but thank you. Christian?
Christian Hops. Aren't these user settable values?
Sorry?
Aren't these user settable values? These limits? Yeah. So couldn't you just set the values to be different?
Oh, you mean for the lifetime?
Yeah, like you're doing this formula, right? Couldn't
Yeah.
you just configure your stuff
Oh,
that way?
yeah, but that the one issue we have is that we would like to have one configuration file and distribute that configuration file instead of handling. This is currently what we're doing. We're handling one configuration per instantiation, and that's a little bit of a headache.
So I think somebody mentioned this earlier, that this isn't a protocol, right? It's an implementation detail. It's a feature. So I think that you might be able to do this as like a BCP or an informational document, but what you really want to do is contact your vendors and say, we want this feature. Right.
So
I think, and if it helps to have an informational RFC to point them at, maybe that's good.
Actually, we would like to implement it. So
it's very easy to contact the implementer.
yeah, that's
so
once. So
Just mirror.
So for example, LibreSwan and StrongSwan implement something called rekey fuzz, where they add a random value to the rekeying parameters, so that you get this more not randomization, but like a spread at the end. So like the default value I believe is 20%. So you've got this spread already. So again, yeah, it's something you can easily do on the implementation, and you don't need to do it on the protocol level. And what Tero said, doing it at the protocol level causes all these people to make the wrong decisions about, if I don't negotiate the same lifetime value, then we must disconnect, which is indeed what happened.
Yeah, at that point, what I'm saying is that I propose a range of count based, and if you disagree, you skip. It's not something that we are not proposing an agreement. It's something that can be skipped, and you fall back to the exact same logic as because you don't have to negotiate. So you can do the way you used to do. It's just a hint. currently the way it is being done. So it's, I mean, you're not mandate to consider that. It's, if we negotiate, I cannot force you to choose one count based. You can say no, not supporting it, and ignore. So, well, I'd like to go on with that proposal, especially given the valuers' feedback. And to see, I mean, if we can end up with either a best practice, or it's even better if we have a best practice as opposed as something to implement. So that's my next step, is probably to take the comments. So feel free to make more comments, and then we can see whether we need these packets, or if we can do without. Doing without it probably better for me.
So one suggestion I have is, instead of negotiating who is the intended initiator and then responder, just use whoever was the initiator when the SA was negotiated, for the 80% versus 95% chance that you had in the other
Yeah.
slide.
So when I think Tero came with that.
Yeah, I mean, then
Yeah,
you don't have to negotiate.
The document. So I remember that in old code we had in early 2000s we were doing this, that the initiator always used shorter lifetime, so it actually had certain lifetime times some constant minus some constant, so it actually get depending, because there gets all kind of weird things when somebody in the stupid QA decides to do rekey every 1 megabyte, and we take 90 or like do IETF negotiation every 3 seconds and so on. So we have to do all kind of limits there, because the QA was wanting to short up their testing times, not waiting for 1 minute to do the rekey. They wanted to do it every 3 seconds. But so there is this different values for recipient and the original initiator, original responder. There was hard limits were actually then if you hit the hard limit, then either end can actually start the rekey regardless of the
Right. So long ago, when I had an implementation of IPSEC, we did that, and so of course the QA people stopped all the traffic, waited until 5 seconds before the expiration, and then sent a ping, which would cause both sides to rekey immediately.
So one reason when I proposed to have only the initiator to be in charge of the rekey, I mean, what they told me that they prefer to have that extra operations to be equally spread among the different instances of the gateway. So.
All right, so I don't see anybody in the queue, and I think so this is now, and my feeling is that it actually is, we don't want to make this as a protocol. Instead, we actually might want to make some kind of implementation guidance, hints, or this kind of document, which actually tells you, and I actually say most of this is, this is one of the things that, different IPSEC implementation differ. I mean, that's one of the things that, which is actually a little bit, hesitant for certain people, might be, not telling what they are doing, because that tells how well your system works under load when doing rekeys, and if they have been tuning these parameters for with the testing for months and so on, they might not be willing to tell it, but some people actually might be doing this, and so having common ways of doing this would be very useful documented. It's something that implementers have to decide anyway, and it's not affecting the interoperability, but it affects the performance and usability of the system. Yeah. So I think it's a basic type of thing is perhaps would be. So I would propose to bring this in the list and talk about more about what would be the useful best method of doing rekeying based on both byte counts or at timing.
Oh, you mean compare the two type of lifetime, or?
I mean, the same issues are both in both. I mean, if you have exactly same times in both ends, you still have then you actually have the simultaneous rekey, unless you have some kind of randomness and different values for responder and initiator and so on.
Okay, right. Yeah. I mean, it's a good the good path, and then we might decide if we need an extension or not from that. But yeah, I'm happy about that.
All right.
Speaking of performance improvements.
Yeah, there are some performance improvements. Nobody knows if they actually need. Oh, sorry. Paul wants to have these.
Thank you. Next slide. So this is just to wake up the working group again about a draft we have going that hasn't seen adoption yet and that we want to see adopted. It's about increasing the performance of IPsec by using multiple CPUs without getting into any kind of contention whereby one CPU limits the other one. So in short, what the proposal is negotiate via IETF multiple child essays that have the same traffic selectors, but they are bound to a specific CPU, and then extend the acquire mechanism in the kernel so that you get an acquire per CPU to the IETF daemon. So the IETF daemon can on demand set up multiple tunnels for each CPU that also starts doing traffic on a certain traffic selector. So multiple identical child essays are already possible, but it's not always clear that they're used for the same goal, or you want to make sure that they're like pinned to the same CPU on the other side. So you want to sort of transfer that information so that both sides can know that this is why you have multiple essays and why you have pinned them to a certain piece of hardware. Next slide. So the 0.0 draft, we tried to cover the two use cases we knew, which was multiple CPUs and quality of service groups. The quality of service groups plus the interaction of quality service groups and multiple CPUs was getting so complicated, and we were not quality of service experts, and no one else stepped in to take on writing that part of the draft better. We decided to remove it completely. So now we're only doing the multi-CPU type child essays. So that was a while ago. Nothing has changed since then. There is an implementation for this in Linux kernel. There are IETF implementations that can negotiate this. So we're pretty happy that that it works. Next slide. So we recently tested with different cards. In the past, we'd used Mellanox. Now we're using the more common Intel i40E cards. In forwarding mode, so gateway to gateway, this is where the host is not actually generating the packet, but just forwarding the packets. Using modern Linux kernels with XFRM, using one traditional IPsec tunnel, you get about 3.5 gigabit per second, and then your CPU maxes out. If you run this draft protocol and you fire up 8 CPUs, then we just got to 27 gigabits per second. So for us, this is clearly really important for use cases where you have multiple connections that you have between data centers, and this becomes extremely useful. People getting 10, 40 gig cards, NIC cards, and they get full traffic, and when the IPsec protected, it slowly drops to 3.5 gig. This is a serious operational issue. So this really solves a problem that we're seeing in real life, and we really like to fix this. And we'd like to be able to for this to be not just a Linux solution, but to interoperate with other vendors. So hence the proposal. The next slide. So yeah, so please read the draft again. And since we saw little feedback, I reworded it this time. If you strongly object to this proposal, please send feedback to the list, which implies that if you keep quiet, that you don't really care that we move forward and take 2 notify code points out of the list of 16,384.
Plenty.
Divided by 2, I think maybe because the arrow ones are different. Anyway, we have plenty of them. We can take 2. So please adopt this or discuss this briefly if you have strong objections, and then hopefully I can poke the chairs in a couple of weeks to move this forward. Thank you. Any questions, comments?
Go ahead, Valerie.
So I just want to say that I just read the draft, and I think it's a good idea. And if the call for adoption is issued, I will support adoption for this draft. but I have some comments, and I think I will send a review after IETF, because there are some things that I think that something can be made simpler, or at least it should be discussed. But generally, I think that it's a very good document, and if IPSECME working group decide to work on it, I will be ready to support this work, to review, to participate. Thank you.
Excellent, thank you. And simpler is always better. So looking forward to your text.
Have
Go
you,
ahead.
Christian Hops, have you talked to, heard from anybody from the other, like the VPP or DPDK guys, Grails?
Not that I'm aware of. Oh, maybe Anthony has.
Are they interested? I think it's a cool idea too, by the way.
I've seen VPP people doing a demo with it, similar, very similar, but they just use a different endpoints, IP addresses. We are trying to use without IP addresses. And then VPP needed each SA to have a different IP address for a tunnel device. So I think the VPP has a similar implementation, and they're not using IKE to negotiate it, but just setting up as a new SA. And so I did send a mail to the VPP guys, and they said, yeah, well, go ahead and we will see at some point.
Yeah, I mean, it's not too hard to implement, I guess, then for them. Yeah, so like that'd be cool, like especially if you got two. But
And the person who was commenting was the Anthony, without mentioning his name. All right, any other comments on this? So you are asking for, I think the working group adoption call, and then we can start working on this.
Well,
Really.
we ask that every time we present. So I think it's up to you, not me. But
Okay.
sure, I will happily issue the working group last call with no hats on.
No, yeah. Yeah. Now you can actually do it. Yes. Oh, can you actually? Because you are not in this group's AD. Okay. Yeah. All right. So I think we actually go to the next thing, that is the charter update and status information things. So our current charter start to be, we are coming to the, doing most of the things we have there. We have finished the PPK, that's already RFC. We have implicit IV, it's RFC. Post-quantum is RFC, and multiple key exchanges in the, process of being published. TCP BIS is going to be in a queue already, and I can't see the slides because it's too low. And TFC and the Young and MIP for it are given to the ISC, though they are out from our hands really. So we still have 4 items in the charter, if I count them correctly. So we have GDOI, we have constraint ISP, we have signature algorithm negotiation, and security labels. Those are the things that are mostly there. I think we might have actually some work also for the, constraint ESP, constraint IKE, but I don't think we have any work happening on those, so that's why it's not listed there. Then we have a couple of work items that are not in the charter. One is the ADD, the IKE version 2 config for encrypted DNS, and IKE version 2 the historic, which those are not really explicitly in our charter, but we have agreed to act as a working group items. And I think the multi-SA performance goes to the same category. It's a very small enhancement to the IKE version 2, and we can actually, our charter has in the boiler text in the beginning saying that, okay, we can do all this kind of, we are doing this small update. But in a sense, I think it would be better to actually start updating our charter, removing old stuff and adding new stuff that we want to add there. But we are not going to do this today because, of course, Rob, we would want to have our AD here. And because we have a spare AD here, not a real AD, we can't really start doing that. Go ahead, Paul.
Paul, just speaking as an author of IPsec IV2 SATS payloads, the reason that nothing happened is because we think it's done. So maybe either we need some more discussion, or we need to consider a working group adoption call.
All right. So yeah. So usually we want to have, yeah. So okay, that's there in the other items things. And then we have this, okay, we have already been working with the MTU detect and the rendered essays. I think both of them actually gets, a little bit, work done. We are not going to be taking them as a work item. The TS payload opt, I haven't read it for some time. I really need to think about it. Diet ESP, is it going to be going here or in LVIG?
The ITSP is going to be here. The reason it has been a little bit silent for some time is that we have described what we want, but Shake has been published on an RFC, and they have another way to express rules. So we would like to use their syntax to express what we do, to do exactly the same thing as what we're doing.
Okay, so all right. I think Valerie is ready to talk about the cookie revised and beyond the 64K, I think. Go ahead.
Yes, exactly. So what about cookie revised? I believe the draft is ready for adoption if the working group want to address this problem, because it's just a problem with, it's a minor problem, but there is a real problem with IQ2. And if we want to address it, I think that we can adopt the draft and follow the way it is addressed in the draft, or find another way to address it. So if the chairs think that the problem is important enough, then also for adoption can be issued. And what about beyond 64K drafts? Well, it is being developed, but we as announcers thought that NIST will select McAleese, and in this case, the draft would be very important. But since NIST didn't do it, it is not so important, but McAleese is still in the NIST list for the next round. So probably it happened. And as far as I remember, BSI, the German organization, still recommends McAleese. It's a national organization, security, and I don't know about other national organizations, but well, I think that McAleese still is considered as a very conservative post-quantum algorithm. So we have an intention to ask for adoption of this draft, but given that the NIST has selected a post-quantum algorithm with smaller public key size, that this is, at this point, it's probably not so important. But it is for the working group to decide, because the problem can arise again in a few years if NIST still selected something like McAleese or some algorithm with very large public keys. And besides, there is another idea that is currently in this draft, that so-called mixed transport mode, when IKE works over TCP and IPsec works over UDP. Again, it may be useful for other things. Well, we have, besides key exchange mechanism, we also have signatures, and signature size is also not small with quantum signatures. For example, even for selected, for NIST selected signature algorithm, as far as I remember, for example, for Sphinx Plus, it's about 45 kilobytes, so it is not, probably it is not a need for something to handle payloads greater than 64K, because it's less than 64K, but it still requires some mechanism for robust delivery of UDP messages, even without fragmentation. So in this case, splitting IKE and ESP transport may be an interesting idea. So that IKE works with TCP and get reliable, robust transport, and ESP works on native protocol or raw UDP and doesn't have performance issues with TCP. So I think this draft should be discussed and probably in some way adopted as is or as some part of it.
Yeah, this Terogimna as a chair, I think this is actually part of our current charter, because our current charter says anything that is related to post-quantum, crypto is in charter. So beyond 64 kilobytes will be in charter in 2 years or something, when the current NIST proposals don't require this yet. So I think what we are going to be doing, what I think we should be doing, probably we should wait for the NIST to be, when NIST publishes that they are having a algorithm that has more than 64 kilobytes of that, then we can actually come back to this and start working on this, because I think it's still going to take several years from there until we actually need the implementations. So I think I would probably put that one on the hold for now and come back to that when NIST comes forward with the, because they didn't pick up any of the algorithms this time. I think we can do that. Does that sound okay for you, Valerie, or do you think that we should push it out even if we don't know how? Because I think it's a little bit different. It's going to be a little bit different if the key size is going to be 100 kilobytes or if it's going to be 3 megabytes. Yeah. I think the mechanisms we are going to be using are going to be different at that point. So I think it would be better to know exactly what we are aiming for before we actually start defining it.
I agree that we can hold this draft and wait for next NIST decision, or if something happen that will change this landscape in post-quantum algorithm.
All right. Okay. Anything else, Valerie?
Well, I have a question to the working group and to the chairs. Is there any interest on working on integration IQ2 with PAKE, password authentication key exchange algorithms? Because this area is developed and CFRG had some kind of selection of PAKE algorithms. And is there any interest?
The question I have there, what should the working group do? Because I think we have already the PAKE, the generic,
yes.
Method of doing that, and all the methods there published in that are information, are not working group draft, they are individual. So I think I was proposing that we should actually pick one and make that as a standard, or which failed last time. So I'm not really sure if we actually want to go back to that.
Well, the current draft, it's your draft, not draft RFC. The framework for integration PAKE algorithm is in informational status, and should we promote it to standards track or not? It's 64, 67. It's I believe, Terry, it's your RFC. Should we start the work to make it a standard track or not?
So Paul was asking if there is any implementation of this draft.
There is. I have implemented
everything, but is there anybody else?
Everybody else.
So I think, yeah, okay, that's one of the things we probably need to think about, but we are not going to be deciding it this time. So actually, so for the charter process, I think it would be best if we now start thinking about, this process of the mailing list. So we actually start going through what items we have in the mailing list, what items we have in the charter, and verify. I did very quickly this morning this, this list here and the previous list. I didn't really go that well through what the charter actually says, so I might have actually missed some items. But anyway, so I think we should actually do the charter update at some point perhaps in either in November, or we should actually to be able to be doing November. So start the process of collecting what items we actually want to put in the charter, and then remove the items that we have already done, and then probably in November we will actually go through the list that are proposed for the charter and see that if there's interest and enough people doing it, then we would prepare the ready charter, and then after the November we would actually go to the AD approval for that. So we actually get updated charter. Any comments or feedback from that? All right, so I don't see anything. So I think we go forward that. Then we have any other business. I think Paul is coming up.
Yeah, just a quick note. If anyone wants to see the multi-assay code in action, Stefan Klaassen here has it running, and he can show you on his laptop. So if you're interested, go to Stefan.
All right. Any other comments? I don't see anybody coming to the mics or anybody in the queuing up in the there, and I think then we are done.
Thank you all. See you all in London.
Yeah.
Cheerio.
And thanks for the note takers, Paul. Thank you. It's European, not European Union.
If Vancouver can count as Asia, then London
No,
can
no,
count
no.
as
Vancouver,
Europe.
Vancouver usually counts as is it Asian or US? I think it both.
Yeah, it's occasionally Asia. Okay, now this is
All right.
I was selected to visit a colleague in Lancaster, and he got us, he approved for a whole week. At what point
Yes, yes, yes.
Just making sure that you don't want me to do.
No. I do it because I usually edit it and fix those way too positive comments people have about their drafts. Oh, we have several thousands of people reading it. Now we haven't really seen those, but oh.
Demo for